Hello friends, this is this problem-based MCQ that I had posted on all my social media accounts this week. It's tough one, I tell you, from NEET PG point of view or INI CET point of view also. This is a tough one. So let's see what the MCQ is and what was the answer and what's the explanation. It's related to the CVS and the ECG part. Cardiovascular status is being assessed in a 40-year-old man. On his ECG, this is the finding. You are recording standard bipolar limb leads, lead 1, lead 2, lead 3. And in that record of these three bipolar limb leads, the sum of voltages from these three bipolar leads is equal to 5 millivolts. Do you understand this? We are taking the QRS complexes in lead 1, lead 2, lead 3. And the sum of those voltages or potentials is equal to 5 millivolts. That's the only data given. And the question is, what does this indicate? Is it the normal heart? Is it left ventricular hypertrophy? Is it the right ventricular hypertrophy? Or is it the abnormal rhythm? You got any idea what this is all about and how you are going to answer this? Anyways, if you just want the answer is this is left ventricular hypertrophy. Why? Let's figure out. First things first. On the ECG paper, on the ECG graph paper, the horizontal axis is for the time durations for various waves. And the vertical axis is for the amplitudes of the waves in the millivolts. So we are recording the potentials and we measure the amplitude vertically. QRS complex particularly, we will measure in terms of millivolts. Okay. Now what is the scale for the vertical axis for the amplitudes of the waves? What is the scale? You must have read that vertically 1 millimeter, smallest box is 0.1 millivolts. Smallest box, 1 millimeter on vertical axis, it is equal to 0.1 millivolt. If that is the case, then 1 millivolt will be equal to 10 millimeters. So hold this thought. On vertical axis, where we are talking about the amplitudes of the waves, if we just draw it here, we are talking about these waves and we measure the amplitude of these waves vertically. All right. And we just now saw that 1 millimeter, that is the smallest square, is equal to 0.1 millivolt. That means 1 millivolt will be equal to 10 millimeters. So please remember this fact. On the vertical axis, 1 millivolt will be 10 millimeters. 10 millimeters on the vertical axis will give you 1 millivolt. I mean, that will be the potential, 1 millivolt. All right. That's clear now. Now let's go ahead. In the given MCQ, the voltage that is given, that is the sum of potentials in lead 1 and 3 and 2. If you add those three potentials, that sum is given to be 5 millivolts. So if 1 millivolt is equal to 10 millimeters, then 5 millivolts is 50 millimeters. That's very clear. All right. So effectively they are saying that the potentials in lead 1 plus 3 plus 2 is equal to 50 millimeters, 5 millivolts or 50 millimeters. And that is where the problem arises, because we have learned the Einstein's equation as 2 is equal to 1 plus 3. That's all we know about Einstein's equation. And here they are saying 1 plus 3 plus 2 is equal to 5 millivolts or 50 millimeters. So how does that correlate? Let's see now. Now is the time to focus and understand all this. Einstein's law or Einstein's equation says the sum of potentials in lead 1 and lead 3 is equal to lead 2. Okay. Lead 2 records highest potential because it's the sum of the other two leads. It means, now concentrate, it means lead 1 plus 3 plus lead 2. Now 1 plus 3 plus 2 is equal to, see, in this means 1 plus 3, we are now adding lead 2 also on this side of the equation will be equal to lead 1 plus 3, lead 1 plus 3 plus lead 1 plus 3 again, because 1 plus 3 is same as lead 2. So we have taken, instead of lead 2, we are taking lead 1 and 3. They are equals, right? Check it out. Lead 1 plus 3 is equal to lead 2. So if we just rearrange the equation, lead 1 plus 3 and add lead 2 in that, on this side of the equation, it will be same as lead 1 plus 3 plus, instead of lead 2, we are taking lead 1 plus 3. Okay. So check it out. Lead 1 plus 3 plus 2, I mean the potentials recorded in lead 1 and lead 3 and lead 2, their addition will be equal to lead 1 plus 3 plus lead 1 plus 3 again. Okay. Which is, because this is the same as lead 2. I hope you have got it. It means further talking about the equation, lead 1 plus 3 plus 2 is equal to 2 into lead 1 plus 3. Isn't it? We saw this here. 1 plus 3 plus 1 plus 3 again. So 2 into 1 plus 3. So now focus on this part. Lead 1 plus lead 3, I beg your pardon, lead 1 plus lead 3 plus 2 is equal to 2 into lead 1 plus lead 3. Right? Got it so far? Now come to the given MCQ. In the given MCQ, lead 1 plus 3 plus 2, I mean the amplitudes recorded from lead 1 plus in 3 plus in lead 2 is equal to 5 millivolts. That is given. 5 millivolts is same as 50 millimeters. We saw that on the ECG paper, on the graph paper. So 1 plus 3 plus 2 is equal to 50 millimeters. Take that. All right. That is same as 2 into lead 1 plus 3 is equal to 50 millimeters. Isn't it? Look, 1 plus 3 plus 2 is equal to 2 into 1 plus 3. Correct? So therefore, if 1 plus 3 plus 2 is equal to 50 millimeters, it will be same as 2 into 1 plus 3 is equal to 50 millimeters. So note this point, 2 into lead 1 plus lead 3 is equal to 50 millimeters. I know it's complicated, but that's how the life is. You know, sometimes you get very tough MCQs. Okay. Now in this patient's ECG, 2 into lead 1 plus lead 3 is equal to 50 millimeters. That's certain. Now coming to the fact that you had to know to solve this MCQ. And the fact is Scott's criteria. Scott's criteria is for the diagnosis of left ventricular hypertrophy. And that according to Scott's criteria, R wave in lead 1 plus S wave in lead 3, if you add these two amplitudes, we are talking about the amplitudes of these waves, R wave and S wave. If R wave in lead 1 plus S wave in lead 2, if this addition is 25 millimeters or more than 25 millimeters, it indicates left ventricular hypertrophy. Okay, that according to Scott's criteria. Now, why is that? We need to understand the cardiac vectors for that. We'll keep it for some other video. For now, please take this, the Scott's criteria. R wave in lead 1 plus S wave in lead 3. Their amplitudes, if you add, and if they are more than 25 millimeters, vertically speaking, 25 millimeters or more, then it will be left ventricular hypertrophy. That means 2 into lead 1 plus lead 3. If lead 1 plus lead 3 25 millimeters addition, that makes it left ventricular hypertrophy. Then 2 into lead 1 plus 3 50 millimeters. If it is 50 millimeters or more, it's the same left ventricular hypertrophy. Is it difficult to understand? If lead 1 plus lead 3, their potentials or amplitudes, if you add, If it is 25 millimeters or more than 25, then it is left ventricular hypertrophy. Then in that case, 2 into lead 1 plus lead 3, 50 millimeters, 25 into 2, 50 millimeters or more than 50 millimeters, it will be left ventricular hypertrophy. Now remember what was the given data. You remember this? 2 into lead 1 plus lead 3 is same as lead 1 plus lead 3 plus lead 2. Lead 1 plus 3 plus 2 is same as 2 into lead 1 plus lead 3. We saw that here. Yes, this step 1 plus 3 plus 2 is equal to same as 2 into 1 plus 3. So 2 into 1 plus 3, 50 millimeters means 1 plus 3 plus 2, 50 millimeters or 5 millivolts. 50 millimeters same as 5 millivolts, and that is the data given. 1 plus 3 plus 2 is equal to 5 millivolts or 50 millimeters. That's according to the Scott's criteria, left ventricular hypertrophy. Okay, 1 plus 3 plus 2 is 50 millimeters, 5 millivolts they have given, same as 50 millimeters. That fits the Scott's criteria for left ventricular hypertrophy, and that's the answer. This is the case of left ventricular hypertrophy. I know it was difficult. You might have to watch the video again to entirely grasp it, and we are going to discuss all such tough MCQs, easy MCQs, and all sorts of questions on our channel. And therefore, have you yet subscribed to the channel? No? Go ahead and subscribe now.